In this lecture I am going to tell you about the general procedure that is adopted for solving a finite element problem manually, and then we are going to see what is the procedure adopted for solving a problem using FEA softwares in the industry. So the first and foremost procedure for solving this FEA problems manually is you need to divide or you need to convert the CAD or geometric model into pieces, say mesh. So what happens when you take the geometric model, you need to divide this particular geometric model into different number of nodes and elements. This particular process of converting the geometric model to the finite element model is known as the meshing. So mesh is nothing but a collection of elements with nodes. Then once we have done converting this CAD geometry into a mesh, then we need to describe the behavior of the physical quantities of each element. So what happens, like for example, if you take 1D bar element, what happens, we need to define the cross section. Likewise, we need to define the behavior of this particular elements. Then once we have done this, we need to connect these elements at nodes and form approximate set of equations. And once we form the approximate set of equations, we need to apply the loads as well as the boundary conditions that are required according to the problem specification. And then once we have done all these things, we need to solve the set of equations. So in order to solve the set of equations, there are a lot of types of solving methods, like you can use the direct solving method for simple problems, you can go for iterative solvers and other sort of solving techniques. And once you have done all these things, you are going to calculate the displacements at each node. And once you get the displacements at each node, you are going to find out the displacement on the element using what is known as a shape function. So for example, see, if I have this particular problem and I solved and I have found out the displacement at this particular node, now what I need to do is I want the displacement value here somewhere at the middle on the element. So what can I do? Instead of solving, I am going to use the function known as the shape function, and then use the shape function to interpolate this particular displacement value to this particular location. Likewise, once you get the displacement solution, then you are going to use the 2D relations or 3D relations or 1D relations in order to convert this particular displacements into strains, and from that strains you are going to calculate the stresses. So this is the general procedure that is adopted for solving an FEA problem manually. Then coming to the commercial FEA software. So say for example, if you are going to solve a aeroplane problem, then what happens? You need to solve number of equations. So is it possible to solve number of equations manually? No. So that is why we are going to use the computer to solve the equations for us. We can either program the total model, or otherwise we can use the commercially available finite element softwares. So some of the examples of commercially available finite element softwares include Ansys Workbench, which you are going to learn in this particular course, and other softwares include Abacus, Naston and other NX simulation and other sort of softwares. Then coming to the steps used in FEA, we are going to have 3 steps. First one is the pre-processing step, and second one is the FEA solver, and third one is the post-processing step. So in the pre-processing step, what we are going to do is we are going to create the geometry, or we are going to import the geometry from the CAD software into the FEA software. And once we have done this particular geometry generation, then we are going to convert this particular geometry into FE model, which consists of different nodes and elements using the process of meshing. Then we are going to define the elemental properties, and we are going to define the loads, boundary conditions and constraints and contacts, other setup conditions in order to simulate the real world environment. And once we have done all these things, then we are going to solve that particular problem. In the solver, what happens, it is going to assemble all the equations and it is going to solve these equations using a technique of FEM, or otherwise it can also use the technique of FVM or FDM or say BEM methods to calculate the elemental results. Once it calculates the elemental results, what happens, all these results will be stored, and in order for us to understand those results, we are going to post process the results. Out of a number of results, we are going to sort what are the results of our importance, and we are going to convert those results into such a way that we can easily understand those results. these are the basic steps that are used in the industry for solving an FEA problem using a commercial FEA software. Then coming to the applications of this particular FEA softwares or these techniques, numerical techniques. So you have different fields of study, like say structural and solid mechanics. You can study the behavior of offshore structures. You can perform reliability analysis. You can perform dynamic analysis, structural analysis, thermal analysis, as well as say integrity analysis, and you can perform lots of analysis. Like for example, see here we have performed a crash simulation where we are going to simulate the crashing of two cars. Likewise, you can also simulate the cooling of electronics. So coming to the field of study, say heat transfer, we can study about the electronics cooling, casting, combustion engines, heat transfer analysis, and other sorts of lot of things you can do using this techniques or softwares. And then coming to fluid flow, you can analyze the aerodynamics, you can analyze the airflow patterns inside a building, HVAC, which is nothing but HVAC, and the seepage analysis through porous medium and other sorts of things. Coming to electrostatics and electromagnetics, you can have the field calculations for sensors, say electromagnetic interface calculations, antenna designs, and other sorts of things you can perform using this FEA tools and the numerical techniques that you have learnt before. In the next lecture, I am going to introduce you to the interface of Ansys Workbench. Thank you.